Hello everybody, my name is Rabee Shamass. I will be presenting my presentation which is about numerical and theoretical modeling of web post buckling of stainless steel cellular beam. This session has been conducted by myself, Rabee Shamass from London South Bank University, and for Professor Federico Guarracino from Napoli University in Italy. The outline of my presentation, I will talk a little about stainless steel in construction, cellular beams, significant methodology, the development of validation of a numerical model, parametric study, theoretical model for stainless steel web post buckling, validation of the proposed theoretical model, and finally conclusion and further work. Stainless steel in construction. Stainless steel has been used actually in construction, widely used in construction. Because it has excellent mechanical property like high strength and high ductility, excellent corrosion resistance property, higher fire resistance, and stainless steel doesn't require any coating. Therefore, the maintenance and rehabilitation cost will be dramatically reduced. This shows a number of examples will be in stainless steel being used either as a cross-section or as a stainless steel rebar. Cellular beam are used in modern structure due to their aesthetic and economic benefits. With floor structural zone can be minimized actually by allowing the passing of surface through the cellular opening of cellular beam. Cellular beams are usually manufactured by cutting along the web of hot roll I-beam section, which is called the parent I-beam section, can be seen in the figure here. And in a certain pattern and reward the upper and lower T to form a cellular beam. And the web post is this area actually between this area, between the cellars, between the circle or opening. This is called the web post area, and this is our interest of this research. Stainless steel has excellent mechanical property like high strength and high ductility, and also inherent corrosion resistance and better resistance to high temperature than the carbon steel. There are no research also into web post buckling of cellular beam made of stainless steel. Most of the research has been conducted on the normal thin carbon steel. Also, the current design tool in literature aim to calculate the shear buckling of web post of cellular beam are not applicable for stainless steel cellular beam because cellular beam stainless steel has exhibited a nonlinear stress relationship from the early stage of loading. In our methodology, we will use finite element analysis, nonlinear finite element analysis, because there are no experimental testing of cellular beam made of stainless steel. The effect of geometric parameter of stainless steel grade will be investigated numerically. Finally, we will propose theoretical model for web post buckling of cellular beam made of stainless steel. Will take in consideration the stainless steel material hardening of stainless steel. In the numerical model, it has been developed for the full beam model, were developed using finite element model abacus, modeling abacus, and is validated against simply supported beams available in literature. And the steel material, actually these beams were made of carbon steel and subjected to a point load at the top. The steel material were modeled with a multilinear stress relationship, which meaning that there is a strain hardening were considered, and the beam and stiffener were modeled using the shell element S4R in abacus. Boundary condition considered to be as simply supported, similar to the experimental investigation, and also the point load were considered on the top of the beam in the displacement control domain mode. And finally, and also the linear and nonlinear analysis were considered in the analysis. So linear buckling used in order to introduce imperfection in the model. This is a model show this model that it is in the top left hand side. You will see that there's a good correlation between the numerical and experimental shear buckling load. And the left hand side and the right hand side top, You will see the stress, displacement load relationship, where that you can see that also that the numerical model can predict the overall behavior of the cellular beams. And the bottom side down here, the second row, you will show that the finite element actually predict the buckling mode of the cellular beam, which is wave post buckling. The stainless steel, in the parametric study, we consider that stainless steel as a parametric study and stainless steel grade as a parametric study, and we know the stainless steel has a nonlinear stress-strain relationship with a significant strain hardening. In our study, we use two-stage stainless steel relationship, as can be shown in the figure here, and this is also can be shown in the equations here, and this is well-known two-stage stainless steel relationship. We use in the parametric study hot roll I-beam section UB 305, 102, 28 as a parent I section, and from that I section we created a number of stainless steel sections which has D0 over D ratio between 0.8 to 1.2, where D0 is the opening and D is the height of the cellular parent beam. And the spacing ratio is over D0, where S is spacing between the circles, and D0 it's opening between 1.1 to 1.5. Different type of stainless steel being considered, different grades, ferritic, austenitic, and duplex. And the mechanical property can be shown in the table here. It can see in the figure here. The figure shows the effect of geometric parameters S over D0 and D0 over 2 TW on the buckling shear load. It can be find out that buckling shear load for cellular beam observes that there is a real positive correlation between the shear buckling load and the ratio S over D0, where greater of the ratio S over D0 will give higher buckling, shear buckling load. Also, there's as a buckling, the shear buckling load increase with decreasing the ratio D0 over TW. Also, this figure will show the effect of stainless steel grade on the buckling, shear buckling load for cellular beams. We consider only one type of cellular beam for presentation here, but we've used three types of stainless steel: ferritic, austenitic, and duplex. And we can find that the shear buckling load for ferritic and austenitic are similar, because both stainless steel actually has similar yield stress, while the duplex has the highest buckling load because it has highest value of the yield stress. And also you can see that the von Mises, the maximum von Mises at the web post for duplex stainless steel cellular beam is higher than the maximum von Mises stress for ferritic and austenitic stainless steel cellular beams. From this parametric study, we can conclude that the duplex stainless steel cellular beam made for duplex stainless steel increased by 28 to 48 on average compared for cellular beam made of ferritic and austenitic stainless steel. And as we said before, that the cellular beam, the cellular beam actually analytical model considered is a high strength, normal strength steel model. So we propose in a different paper published Shamass and Guarracino 2020, we propose a model that improved theoretical model for wave post buckling of cellular beam made for normal high strength steel. And this model is based on classical truss analogy. But our model is based on both geometric and mechanical consideration, where adopt the weight, inclination, boundary condition, mechanical probability of the ideal strut to the geometry and material of the cellular beam. For more details, you can find out actually in the paper Shamass and Guarracino 2020. Show here some figures of showing the basic geometry relationship, length, width, inclination of ideal struts, where the inclination, the length, and the width of the ideal struts were taken into consideration from the geometry and material. Once the geometry of the strut was considered, The buckling load can be calculated using this equation QC. And finally, this equation you has n taken as a 2 because this is wave post buckling is a 2 waves buckling, and zeta is taking into consideration the value the boundary condition by setting xi equals to 20. And finally, we can find the shear buckling load using the equation V here, and the graphical representation you find it is here, where Q is the shear load and the QC is a buckling load of the struts, and QT is a tension. You know the tangent modulus is the tangent modulus ET of stainless steel depends on the level of stainless steel. Level of stress, at the buckling load that can be calculated dependent on the two-stage equation presented before. But if we use that equation, we're gonna have a complex buckling load, a complex relationship, which is the iterative method. So we use this is a bilinear relationship with stainless steel, which is widely also used. C2 in this equation should be identified, and the value of C2 is 0.015, 0.023, and 0.032 for ferritic, austenitic, and duplex stainless steel respectively. From this here, you can find out that the stainless steel actually does an analytical model compared with the experiment with the numerical. It can be found that analytical model give a very good correlation. Good prediction of the shear wave post buckling, shear buckling of wave post buckling. In some cases, it's underestimated, so we can conclude that the model is valid and give a very good result. We conclude that the grade of stainless steel geometric property has a significant effect on wave post buckling or buckling load. And the proposed theoretical model for wave post buckling proposed by Shamass and Guarracino 2020 for normal high strength Z can provide a good shear buckling protection for wave post by cellular beam made of stainless steel, and it can be easily account for strain handling of the material. But for further work, find out that given a strong sensitivity of the analytical analysis to actual value of tangent modulus ET, in order to refine the proposed mechanical model and to assess the value of the parameter C2, that parameter we talk about, in a view of an efficient and sustainable design guidance, additional experimental and numerical investigation should be required. Thank you very much for listening to the presentation, and this is a list of the paper research references, and the most important one is the reference number 7, where this research is based on this reference number 7, Shamass and Guarracino numerical analytical analysis of high strength steel cellular beam. Thank you very much. And